Yes. Hello, good afternoon to my class. I am Professor N.K. Pandit from EC Department, Haldia Institute of Technology. The topic of this today's class is control systems. It's a very much an engineering core subject, and you will study the different aspects of the control systems used in practical work, right? So this is the introduction to control system to have some introductory concept ideas of control systems. It is an automatic based systems, automation system control, and it plays a vital role in engineering, science, or any practical plants. The examples are space vehicle systems to control aircrafts or satellite rockets or missile guidance systems, which are very popular these days, or robotic systems like this, which controls many different operations in industrial plants. So what is the definition? What are the parameters? What is the important parameters in a control systems that we will now focus on in this slide? So these are the control. First is the control variables. What are the variables you are controlling? You are controlling like temperature, pressure, velocity, accelerations of the system. What is the manipulated variables that is verified by the controller? So the effect of the control variables are affected. Plants, which is the main piece of equipment which you are trying to control in an industrial factory or a robots or a space vehicles or an aircraft. Processes, the chemical processes or biological or electronic combustion processes like systems, combination of compartments that performs a certain objective. And the disturbances, these are the noises or these are the noises from the external environment, noises factors that disturbs the operation of the system. And feedback control, that is important, that will help to control your systems even in the presence of disturbance from external world. So these are the architecture or the block diagram of the feedback control systems. You can see the controller, which is the main intelligence of the system, the actuator, which actuates the different processes of the plants or the robots, the robotic hands, manipulator, etc., or the combustion process, and the sensor, which senses the different parameters to be controlled, and they are fed back, and the error is calculated by how much it is deviating from the ideal response, and accordingly the controller takes the action to control the minimize the error, right? So this is the architecture or block diagram of a closed loop feedback control system. So what are the examples? What are the practical examples of the control systems? Like the speed control systems, you can see the speed control. You are controlling the speed of the engine, load, the motors, and the engines. So these are the fuel input. Fuel input, it takes the fuel and the mixture mixes with air. Air fuel mixture is combusted, and you can control that there are different valves. And in properly controlling the different valves, you can control the velocity of the motors and the engines and the combustion process. So this is the speed control system. This is one good example of a practical control system. So, one second is the robot control system. You can see the robotic manipulators, robotic hands, which actually positions the hands to the desired object. The actuator actuates the motors that control the robotic hands, and the manipulator is the power source and the control that guides the robotic hand to the actual object or target, right? So you have to divide the input and output devices, and you have to design the proper control algorithm for the controller so that the manipulator finally lands on the desired target very precision, in a very precise way, and with very high precision. Right? So these are robot control system and feedback signal from the sensors. The feedback signal goes back to the controller so that you can adjust the error and finally convert this to very low. Third and very good example is the temperature control system. You can see you can control the temperature by sending proper current to the heater. There is a relay. By relay, the heater you can on and off. And that's controlling the DP cycle. You can control the temperature of the heater. There is AD converter, amplifier, and amplifies the current. And properly, there is a feedback control system. By properly controlling the current to the filament, you can control the temperature. Right. So this is an example of a temperature control system. How the temperature control of the passenger compartment of a car. There is a heater or air conditioner. Either you can heat or cool down the temperature depending on the current to the filament. So radiation, you can radiate it out by cooling. By the controller, the sensor measures the temperature And by there are two temperatures, ambient temperature, sun temperature. Depending on the sun temperature, when either heat or cool down the system so that it reaches the desired temperature and the passengers feel comfortable. So this is the example of a temperature control of a passenger compartment of a car. So what is the difference between closed loop and open loop control system? In actuating the different error, there is not much control in a open loop system. The error may go high, quite high, and it is not under the control of the controller. But in a closed loop feedback system, the error is very low, the precision is high, and you can get the desired point or desired target value of the actual output, right? So closed loop system will be much better than a open loop system. You have to design the proper control algorithm to design the closed loop system. So what is the disadvantage of the open loop control system? There's no effect on the controlling action. The accuracy of the system depends only on the calibration. The relationship between input and output is not known, and there is no external disturbance, right? An advantage of the closed loop control system is the fact that the feedback makes the system response quite insensitive to external disturbances. The external disturbances doesn't affect much the desired target output, and from the point of view of stability, those are going to seem easier to build, right? So open loop system, what is the advantage? It's simple but easy to maintain, it's less expensive, but there is no stability problem. But the output is hard to measure, and measuring the output is precisely economically and feasible, but there is no guarantee on the output. The output, the error may go high enough depending on the calibration, so it is not much precise, right? Open loop disturbances and change cause errors. And to maintain this required quality, they have to recalibration necessary, so that is quite disadvantage. Right? But